Hey guys, welcome back. One of the things that is important for erosion control is doing a temporary sediment basin or a temporary sediment trap, and that collects water or runoff from the site and prevents silt from leaving the site. So in this example today, Michael's going to walk us through how to size a temporary sediment trap and show us how to do that for a project. So let's learn.
Hey, this is going to be a video of sizing and designing a temporary sediment trap, specifically a rock outlet style sediment trap. So it's best to use sediment traps if you can as a form of sediment storage opposed to using a sediment basin, just because they're easier to design, easier to construct, and cheaper in general. You can only use a temporary sediment trap if your drainage area going to the trap is less than 5 acres. There's information in the green book about how to size the trap. I'm gonna pull up a picture of one. Yeah, they basically just look like this. It's kind of just like a hole in the ground with an overflow. They're nothing crazy, and then it's got, like, you can see the rock overflow on this side. It's just a way to store the sediment, and then when it fills up 2/3 of the way, or a third of the way, the contractor's supposed to clean out all that sediment or mud. So the first step is going to be to figure out how much area on your site is draining to the temporary sediment trap. So that was done previously for this site just to kind of speed up the process. So this area here, you can see this thick zero layer line. It's 1.34 acres. So that's what we're going to use to figure out how to size the temporary sediment trap. Sometimes you'll have multiple temporary sediment traps on site, and you only have to size them for the area that's draining to that specific trap, not for the entire site. So we have this calc that's set up, that's in our blocks table. Where's the blocks? If you go to phase 1, it was over, I think it was sitting right here, but we must have just moved it over. That's the calc for the temporary sediment basin. Well, I guess it's the same one, so you can just copy this over and rename it temporary sediment trap, which we've already done. Update the area, which for this one it's going to be 1.34 acres. The next line, minimum storage. The minimum sediment storage for a trap on site is, or a basin, is your area times 67 cubic yards per disturbed acre. So that's where that 67 cubic yards comes from. So it's 1.34 times 67, which is 89.78 cubic yards. Sediment storage provided, that is for after we size it. Clean out storage, the contractor is required to clean out the sediment trap after it's filled up a third of the way, which 22 over 67 is 1/3, so that's where that 22 cubic yards comes from. And then clean out elevation to be marked on stake at riser. We'll get that from using the pond design template, but we don't have it yet. So now we know we need a minimum storage of about 90 cubic yards, and everything on site, well, after we put in this diversion ditch that's running along here and this diversion ditch over here, most of the area should get to this temporary sediment trap. If some of it goes to the silt fence, that's fine as well, but we're going to size it for all going to the sediment trap. So if you hop over to phase 2, I would grade it out here so that you're not, conflicting with your phase 2 grades. So this is the contour here. So basically the goal is to get a temporary sediment trap in the ground right here that will, when it fills up, it will overflow through the rock and go down that way. So usually I'll just quickly sketch in what I think it should look like, and just to see if it's going to be the right size. So this is 68 66. So it'll look something like this. I messed that up. So this is all higher than 66 on this side, and then it's lower here. So that's gonna, when it fills up, it's gonna spill out that way. Want to make sure if this is 68, make sure this is at least 4 feet away from there, so it's a 2-to-1 slope. Maximize our area we're using, and this is just kind of rough just to see if this is even going to be enough area for it. So we know we're far enough away from the 68. We'll delete that. We'll round it off some. And then, so 66, we can go to 64. And then we're gonna come back and clean it up. I just wanna check if it's enough size. (64, 62, 60). So this one would be 6 feet deep, which is it's getting kind of deep, but let's check to see if that's enough. So the bottom I'm just gonna call 0, 2, 4, and then for this next one, if this represents 6, there's going to be spots in here that are maybe like 2/10 lower than the 66. So if I grab a spot elevation, we'll say this is like 65.8. So if it's a 2-to-1 slope from the 66, you'd offset it 0.2 times 2, so 0.4. And this would represent our 65.8. No, something like that. Because we can't claim storage all the way up to 66, because at 65.8 it starts overflowing. So we'll put 5.8, and now we'll check to see how that looks for the volume. So if you go up to Analyze, Create Design, no, not Analyze, Design, Stage Storage. This is how you can use the stage storage tool to see how big your pond is or temporary sediment trap is, just based on the contours that you graded out. They have to have elevations assigned or it won't know there's any volume. So define basin from polylines, define, you select just the polylines for your temporary sediment trap. So we have 3,889 cubic feet of storage, which we're going to need to get into cubic yards. So if you take that and divide it by 27, it gives you cubic yards, which is 144 cubic yards. So we only needed 90, and we have 144. So we can go back and make it smaller. What I'm going to try first is just getting rid of this bottom contour. So it's just going to go from 62, 64 to 65.8 and keep the same footprint. So let's see if we go back into stage storage, define basin, define from polylines, define, select your contours. Now we have 3397 cubic feet, which is 125 cubic yards. It's still too big. I'm going to keep the same depth that we have. I think there's a minimum required depth of 3 feet, so I just don't want to make it much shallower. Instead of making it shallower, I'm just going to reduce the footprint. So you would just go back and maybe we're just going to pull everything this way until it gets to what's 90 cubic yards to cubic feet. We need about 2,400 cubic feet. So let's just make it smaller. We'll see how well I am with the stretch tool here. Probably not that good. Stretch. Midpoint. Oh, there we go. Oh, I just undid it. Stretch from here up to there. That's probably too small, but let's try it. That'd be nice if that works. So design, did that change the elevations? Nope. Design, stage storage, define basin, define from polylines, define 2248. It's just barely too small. We just need to stretch it a little bit more. It worked the first time.
Oh, yeah.
We're really close. So if we go back, design, stage storage, define basin, polylines, click, click, click. 2548, which is 94 cubic yards. I say we run with that. So if we go back to our erosion control plan, there it is. We update the calc. So we'll say we provided 94.4 cubic yards. Well, I guess we did hundreds over there, so 94.37 cubic yards. And now the last step is to figure out the clean out elevation that needs to be marked on the temporary sediment trap. So we'll open up our pond design template, which should be sitting in our hydrocalcs folder. If it's not, we'll have to go grab a different one. So it's in documentation, stormwater, hydro report template, pond design. So we'll copy one of those over. And we'll name it sediment trap design. So the goal of this is to just figure out what clean out elevation needs to be marked in the temporary sediment trap. So when it's filled up a third of the way, it's supposed to be cleaned out. It's like if this is the section view of the sediment trap, we're trying to figure out at what elevation does it fill up to, what was the volume, 29.48 cubic yards. And they'll literally just put like a stake in the ground at the bottom of it, and it'll just have like a little marker on it. They'll probably just mark it with them. I don't know exactly how they do it, but when it fills up to that level on the stake, they just need to clean it out. So if we go to the pond volume sheet and we clear out these and these, we type in our elevations. So this is gonna keep disappearing. That's annoying. 309. I'm just gonna write these down. So at 62, it's 309 square feet. At 64, it's 677 square feet. And at the 65.8, it is 1101 square feet. So if we take those numbers, plug them into here, so 62, 64, 65.8, the areas are 309, 677, 1101, and then these columns down, or these rows down here, you can just type in any volume into it. It doesn't matter that it says like 2-year detention volume, 5-year. You just type in any volume and it'll tell you at what elevation do you hit that volume in your pond. So we want to know when do we hit the 29.48 cubic yards. So we have to convert it to cubic feet because our pond design spreadsheet used in cubic feet. So 29.48 times 3, that would be 88.44. Not 3, 29.48 times 27. 795.96 cubic feet. And that means our clean out elevation we marked on the stake is 63.7. So 663.7.
1060.
Yeah, 1063.7. The layer that this goes on is the CE12 BMPs. It should show up on phase 1 and 2. And then you'd want to make sure to, put your label over here. But that kind of wraps it up. I'm going to go back and clean this up a little bit so that everything's even and it's a 2-to-1 slope, and that's kind of looks jaggedy right there. But that sums it up for how to design and size and temporary sediment trap.